Hi, in a couple of weeks, I will be presenting at DevFest Strasbourg, and I will be giving a presentation about our approach based on migration pipelines. And today, I've been working on the presentation. I want to make it more practical than the one that I gave at CodeMotion. And so here we are. I wanted to share with you this example so that maybe I can get some feedback. And anyway, I need to rehearse the presentation, so I could do that online. Now, I want to start by showing this piece of RPG code. It may look like Greek to you. You may not understand what it is. It doesn't matter. We will go into that step by step. But basically, this very simple piece of code compares two values, and if the amount is above the threshold, is called some function. Now, we would like to translate this piece of code is an equivalent piece of Python code. The first thing we need to do when we want to migrate this code is understanding the structure, recognizing the different elements that appear. This will be, no surprise, the job of the parser that will go over the code and recognize, for example, that at line 1 we have a declaration of something named amount that has type 7p2, which means a number stored in packed format. This number has 7 digits, 2 of which are decimal. Let me change perhaps the layout. Sorry, got a call. Oh, it's difficult to change the layout, apparently. Well, let's forget then. No, this one was the one that I wanted, sorry. Now, we have another example in which I show a declaration of this time a variable named threshold of type 5i, which means an integer, basically with 5 digits. And then I have a couple of assignments. I assign 100 to threshold and 125.75 to amount. Now, I later have an if statement, and this is a little bit of a strange format, typical of RPG, where I can pack sort of a comparison and an if, and this means if amount is greater than threshold, then execute the body of the if. Now, what is important in this example is this. You can see that the assignment to threshold is translated very simply in Python, while the assignment to amount is slightly different because we don't take the value as is, but we instantiate an instance of decimal, a special class that we have in Python to represent number more precisely. Now, what is the problem here? The problem is that we are translating two constructs with the same structure, but in different ways. And if we look at the information of the element we are translating, there is no int that we can use to decide that we want to translate one statement in one way and another statement in a different way. So how do we know? How do we understand that we need to treat them differently? Well, in this case, the key is to look at the different assignments and connect them to corresponding declarations. We do that through a process that is called symbol resolution. In this way, we can say that the assignment at line 6 refers to the declaration at line 1. Now, of course, this example, this is trivial, but in general, we need to support all the scoping rules that we have in languages, and they can be also fairly complicated. Once we connect the usage to the definition, in the definition there is the type description, and so we can understand that this is a decimal number and therefore taking that into account when translating it. Now, let's see another things that we may, another situation where we need to find a smart solution, let's say. In this case, we have some gotos. And gotos are a problem when migrating to modern languages because typically modern languages do not support the goto statement. So what do we do? Well, first of all, we can look at some gotos and verify that, for example, this particular goto point to the start of the loop, while this particular goto point to immediately after the loop. So it jumps out of the loop. So we are seeing two different gotos that have different roles, and we need to leverage these to decide how to translate them. In general, we can do that performing control flow analysis. So we take the structure that we identified at the previous steps after we resolve the symbol, so that, for example, we know that a certain goto is connected to a certain tag, and we use this information to identify what are implicit loops that are not defined explicitly as in modern languages. So we don't define them using a do or a while or other control flow structure, or we are not forced to, but we typically do that by using a combination of gotos and tags. In this case, once we have this graph, we can look at it and identify a loop. And then we can see that certain jumps are jumps inside the loop and other jumps are jumps outside of the loop. So let's just recap. We first of all recognize the structure of the code. So we recognize the declaration, an assignment, an if, and so on. Then we identify connections. So we identify an assignment, we connect an assignment to a corresponding declaration so that we can read the type. And then we can do further analysis depending on the kind of problem we are dealing with. For example, we can do control flow analysis to mark certain gotos as gotos that jumps out of a loop or within a loop. And we can use this information later on to perform our migration. So we went a little bit quickly, but we saw the first part of a migration, the part where we understand the code. In the second part, we will use this information to actually generate migrated code. Thank you. Bye.